One last piece in section 4.3, and that is something called definite integral properties. There are 5 properties. We're going to go through each one, and then I'm going to show you examples of how I've used it in class and how Delta Math uses it as well. I actually kind of like when integral properties questions show up on the AP test because they tend to be pretty short and pretty straightforward. Every now and then they'll throw one in there that try to confuse you, but for the most part, they are relatively quick. So our first property of definite integrals doesn't have a name. It is the idea that if my definite integral starts and ends with the exact same number, no matter what the function is, you're always going to get 0. And the reason why this is true is if you start your area and end your area at the same value, you don't create any area. And sometimes I've seen this show up on an AP test and they'll make it look like it's going to be really complicated. They'll put a trig function in there like the one I showed you. They'll make the boundary some really obscure value, or in this case pi, just to make you think that it's going to be harder than it is. You're going to get 0 because you don't go anywhere. Second one is a property that you're going to get more insight into why this works in future sections, but it's what happens if you actually flip-flop your boundaries, and instead of going from the smaller number to the bigger number, you go from the bigger number to the smaller number. If your boundaries switch, it actually negates your answer. So for example, if I went from 0 to 3 of the function x plus 2, if I were to draw it, you could actually see the area that's created. You end up getting 21 halves or 10 halves, 10.5. If the boundaries were flip-flopped, the answer that they expect is actually the negative of that answer. So you would get a negative 21 halves. We'll definitely get into more of why that works as we get further into this chapter. The third property actually has a name. It's called the additive integral property. I usually call it part plus part equals whole. So what this is saying, and I think this one's easier to explain with a picture. I'm going to draw it down here. If you're going from A to B, and somewhere in the middle of it you have this value C. So we'll say we have just some random function here from A to B. All this property is saying is I can stop partway between A and B and add up the 2 areas and I'll get the same answer. So what it's saying is if I go from A to C and I get that area, and then I go from C to B and I get that area and put them together, my answer would be the same as starting with A and going all the way to B. Very much like a geometry concept, part plus part equals whole. So the example I have here is if I go from 0 to 3 and get 6, and then I go from 3 to 7 and get 4, then that means going from 0 all the way to 7, I would add the 2 parts together is 10. So that's a part plus part equals whole. That property itself is used so much on the AP test, and I'll show you as we do examples how it's used. Our fourth rule is called our constant rule, or sometimes it's called a scalar rule. And essentially what it says is if you put a coefficient in front of this function, you can put it in front of the integral or in front of the function. All it does is it multiplies the answer by that scalar. It is just a multiplier. So if we take the previous one where we said the integral from 0 to 7 was 10, so what we did right over here, now it's saying, well, if I do the same function, the same integral 0 to 7, but I put a 3 in front, I just multiply that 10 by 3. So it multiplies by that scalar, and I get 30. And then finally, my last property is a sum and difference property, and this one's very straightforward. The idea that I can take definite integrals of functions that are added or subtracted or both, and I can add them up or subtract them or both. So essentially we can go kind of function by function and add the pieces together or subtract the pieces together, which hopefully is something that seems pretty natural with these. So let's practice. The nice thing is you'll never have to name the property you use. It will strictly be asking you to use it, so you don't worry that if you're not going to remember some of the names of these properties. So in this one, I'm giving you a certain information about a function f, all definite integrals here, and asking you for integrals that we can kind of build off of that. So for number 1, if I want to know the integral from 1 to 10, well, I already know the integral from 1 to 4 is 5 from right here. And then I know the integral from 4 to 10 is 10. So I'm going to add those up, part plus part equals whole, to get my answer. If the boundaries were switched, I do want to mention that because that shows up a lot. If instead of going from 1 to 10, it went from 10 to 1, you would actually get your negative answer. So you can kind of use some of these properties interchangeably. Number 2 wants to know what happens when I integrate from 1 to 10, f and g added together. Well, I just found out that from 1 to 10, f was 15. And then they tell me from 1 to 10, g is 14. So if I add them together, I get 29. As you can see, these are fast. The third one is the super quick property. Because the boundaries of integration are the same, I'm just going to get 0. And then the fourth one is the negation. So if I know from 4 to 10 is positive 10, then from 10 to 4 is negative 10. So that's how you use those properties kind of all together. So let me show you what delta math will do. Delta math will always tell you it's a continuous function because if it's not a continuous function, we can't do integration. And then it will give you some given information and ask you to find something that relates the given information. So this one says, I know from negative 2 to 10 is 1, and I know from 10 to negative 3 is negative 5. What happens if I go from negative 3 to negative 2 and double my function? So this one's using a lot of rules all in one problem. So here's what I'm going to start with. I'm going to start by writing what I know. I know that if I go from negative 3 to negative 2 of my function and add that to negative 2 to 10, I'm going to get the entire integral. So I'm kind of thinking of it like working along a number line. Negative 3 is the smallest number that's mentioned, and positive 10 is the biggest. So I'm going to do a part plus part equals whole. So now let's plug in what we know. So we know from negative 2 to 10 is 1. So I'm going to replace that. I'm trying to figure out this one. So this one is the one, I'm going to call this like x. And then I basically turn this into an equation. And then I know the integral from negative 3 to 10 is going to be the opposite of the integral from 10 to negative 3. So it's going to be 5. So that means this integral that I was trying to figure out must be 4. So my integral from negative 3 to negative 2 is 4. Finally, don't forget that we are also doubling my answer. So that's that scalar or that multiplier. So since I figured out that the integral from negative 3 to negative 2 was 4, since I have to double it, I'm actually going to type in 8. So you kind of have to build it up by working with your knowledge. Turn it into an equation. It makes life so much easier for you. So this one tells us, so my given information is what's happening from 9 to negative 1 and what's happening from 10 to 9 to 10, and wants to know what's happening from negative 1 to 10. So again, I'm going to write part plus part equals whole. The smallest number I have is negative 1. So if I go from negative 1 to 9, and then I go from 9 to 10, that will give me the integral from negative 1 to 10. And I always go in numeric order and then adjust if I need to. And I also don't take the time to write f of x dx every time. So from negative 1 to 9 is going to be the opposite of this one, which is 9 to negative 1. So it's going to be positive 1. From 9 to 10 is 3. And that tells me that the whole thing, and that's actually what I'm asking, this one's a little easier, from negative 1 to 10 must be 4. And that's what you're going to type in. If you can turn it into an equation, part plus part equals whole, and then start building, it makes it so much easier. Here's the last one. So this one gives us what happens from negative 3 to 4, from 4 to 9, and asks us what happens from 9 to negative 3 of a half of that function. So again, part plus part equals whole. So if I go from negative 3 to 4, and then I go from 4 to 9, I will get from negative 3 to 9. So from negative 3 to 4, I know that it's negative 7. And from 4 to 9, I know it's 4. So if I add those up, I know that from negative 3 to positive 9, I get negative 3. But look at two things that happened. The boundaries got switched. So notice here, my boundaries are flip-flopped. Very common thing to do on the AP test. So my answer should actually be negated. It already was negative, so I'm going to make it a positive. And it had a scalar. It had a multiplier. So whatever answer I get, I want to multiply by a half, which gives me 3 halves, or 1.5. They would accept decimal or fraction. So that's how you take those 5 properties and kind of jumble them together and utilize them in finding unknown definite integrals.